in academic institutes like JSS STU, JSS AT Noida, and JSS AT Bangalore. And also to explore the scope for UG and PG courses in semiconductor technology. I welcome our moderator, Sri Shiv Shankar, Chief Executive, SJC STEP Mysore, onto the dais, Dr. Shiv Shankar. We also have panelists from industry, Dr. Natarajan Krishnan and Sri Paul Ilangovan from Keynes. Please occupy your seats, sir. And from the academics, we have Dr. Subindra Kumar K and Mr. Vijay Kumar MD. Please occupy your honorable seats. So I welcome all the four panelists and the moderator to this panel discussion. Over to Sri Shiv Shankar to kickstart the panel discussion with the agenda given. Thank you, sir.
Right. Thank you very much for having this wonderful session on semiconductor technology, center of excellence, and opportunities to get the courses is very much where we stand with respect to the global perspective. Why this particular aspect is very necessary in this particular 3 day conferences on skilling the future, the trends, and challenges in semiconductor technology. Let me put the perspective. I had an opportunity to interact with one of you yesterday. Last 2 years, other things have been panning out in this particular sector, semiconductor industry itself. I've been around different platforms, taking a Singapore, Dubai, and Indian conferences so far in the last 18 months. One of the hot topics in Indian subcontinent as well as the global platform is another semiconductor which is leading the industry trends for most of the other sub and related functionalities of the industry are in component industries or maybe why these particular things are happening, what are those things, what we need to take a look at it, and our having anything prepared is more important. So considering we have the families coming from both academic setup and as well as industry setup. So we need to see where the starting point for academia in terms of the Indian COE and as well as the post 2 years or the post content for both UG and PG programs. What is the value creation guarantee? Why this aspect is important today, knowing both their academic entities and also the research side, industry, they know what the value creation is already coming from. Semiconductor, as they know, one vertical industry, $700 billion worth in industry kind. And what it means, another revenue generation is part of the other products that perform in the industry. That is actually around $3 billion industry kind of thing. Doesn't it make sense? We go back to 25 years back. The IT, internet, things happen. Computer science was very nascent stage and how the things are evolved. And this is also one of the time periods where in which along with the semiconductor, innovation in other technological frontiers, whether maybe artificial intelligence, maybe IoT, or maybe robotics. The core influencing factor on each of these industries is coming from the semiconductor space. It means that the advancements in the semiconductor is influencing every other branches, every other department, and every other technological innovation factor. studies, strengthen our system where this particular semiconductor industry is in forefront to lead or maybe influence other sub industries or maybe subdomains, either in the verticals or the horizontals of the business. So straight away into that, the topic for us is opportunity to have doctor and UG and PG courses. So I'll go across the panelists as a brief for the benefit of the audiences. I request each one of you to have a brief introduction of yourself so that from there.
Hi, so good afternoon, everyone, and I hope you have a very good lunch. So thank you for you. I would like to extend my sincere thanks to the hospitality which you have given, and I've enjoyed the stay yesterday and today. Coming to my profile and coming to my experience, so I have around totally 34 plus years of experience in combined academic and VLS. So initially after my graduation, I did PG, that is ME in digital electronics. For 9 years, I served as a lecturer in one of the premier institutes in Karnataka, and that was in electronics and communication. Later in the year 2000, I entered into VLSI domain. From this, so the VLSI saga started. Yesterday, I gave a presentation on how the journey of electronic industry, of the digitalization, how the miniaturization of things, and 2000 to 2000. And I'm currently working in taking care of physical design activities. So I'm taking care of all the activities. Thank you very much.
My name is Dr. Surendra Kumar. I have 30 years of experience in both industry, government, and academics. Currently, I am a domain head of VLSI and embedded systems, and also head of a COE called Center for Hardware Acceleration and Chip Security, where we consult with both government and corporates at PES University. Thank you. And again, going head to the founding Swamiji of this great institution. And again, I have seen this means one of the greatest institutions which has produced so many good engineers to the ecosystem. So JC is always a place where it churn out the best engineers. And again, one thing I want to say is all our most of the creamy students who get passed out of 12th standard during my counseling after NITK, at the time was KREC. After that KREC, the choice was 3 good colleges, maybe the RV, was the JC was that. And again, one thing I want to congratulate JC alumni is that they build the nation actually. Means wherever you go to the any government organization, any other organization, any L&T like company, we find a JC engineers at the top positions, building bridges, building nation actually. All IIT, NIT graduates go to US, UK and all, but the JC engineers build the nation. So thanks to JC.
Good afternoon, everyone. My name is Nadarajan Krishnan. So I have lots of experience in the semiconductor industry. I did my engineering from Annamalai University in Tamil Nadu and my master's in the US. And I worked from multiple semiconductor industries in the Silicon Valley for almost 25 years before I moved back to India to contribute to this industry revolution happening in India. So I'm glad to be part of a community like this. And I'm also looking forward to the next step of actions we are going to take here after this discussion. And I'm very glad to be part of this whole ecosystem. Thank you.
Good afternoon, all. My name is Paul Ilangovan. I am representing Keynes Semicon. You're surprised to see that a mechanical engineer being in a semiconductor field. So basically, I am a mechanical engineer in bachelor's degree, After that, I did my MTech and MBA. So I have 30 years of experience, out of which 25 years into the semiconductor packaging industry. I think many of them are in the design side, but I am the one in the packaging side. Many of us don't know that India has the semiconductor since 1980s. The first one was established as SEL Chandigarh. So then Prime Minister Indira Gandhi ma'am was established that, but unfortunately, it got fired in 1988. Nobody knows the reason behind that. Otherwise, India could be the pioneer in semiconductors. Similarly, in 1987, a company in Chennai started in the semiconductor commercial manufacturing, a company called Spill Semiconductors. So I was part of that for about 21 years. Then I moved to another company in Rajasthan, Sahasra Semiconductors, where they manufacture the memory products. I was there 3 years. I was very fortunate to establish the unit from the day one. Then I moved to Tata Semiconductors, then joined Kane Semicon past 6 months. I'm here. So it's good to see you all. Hopefully, from the packaging side, I can clarify your doubts. And in fact, we are working with a couple of industrial and other academic institutions on establishing the COE and preparing the curriculum for them as well. So I can share my knowledge with you all. Thank you.
For like, I think mechanical engineers and electronic engineers is like place of the industries as well. It's often like that. Same, I was mechanical engineer being in ecosystem, working in aerospace, but majority of the things what we see is these two departments is kind of a interconnected, interrelated, both horizontally as well as vertically in that aspect. What it means, and straight away come to you because industry is happening in India and subcontinent point of view. It start with in India as on today.
See, actually, 15 or 12 years back, when Dr. Manmohan Singh was the Prime Minister, we have signed a couple of MOUs to establish the wafer fabs in India. But at the time, due to some reason, again, it's all political reasons. We don't aware of all those stuff. That didn't happen. But fortunately, this government has pay attention. That is one reason is that the geopolitical, because most of the companies who are there in China now they are coming out of China. So they look for a country where they can grow, and they found that India could be a best option. So meanwhile, the government also formulated the policies and where it grows up. As of now, there are 4 companies where the government has given the approval: Micron and CG Semi, Keynes, and Tata Semiconductors. So Tata will have 2 plants, one on the packaging side and one on the wafer fab side. In addition to that, there are several applications are there, close to 7 or 8 semiconductor companies applications still with the ISM for their review. So in next 3 to 5 years time, India will be on the top on the semiconductor side. But before we go into this, I just want to clarify you, because many of them think that semiconductor is only a fab. It is not like that. So you know all the process flow, right? A concept that converts into a design, then design goes into the foundry to manufacture as the silicon wafer or silicon carbide or gallium nitride wafer. So that is the foundry or fab which we call. Then that silicon wafers come to us where we do the packaging. We do the packaging based on the customer's requirement. In semiconductor, there are plenty of packages available. We may call it as the through-hole packages, surface mount packages, which we call QFN, DFN, SOPs, PDIPs. Then we go for BGS, ball grid arrays, flip chips, wafer scale packages. And nowadays there are advanced packages like 2.5, 3D, all those kind of, is the elevation of this kind of thing. So to answer to your question, definitely India will have a bright future on the semiconductor side. But unfortunate thing is that the skill set. That is a big challenge for us.
That's the reason exactly, why we are discussing this option today. Put it across, what Paul has mentioned from the, triangle's point of view. At the top of the this industry, we have foundries, which is currently, like, specifically tell, only Taiwan as leading that trend across the globe. Operating in this. The next, all the rest of the things is being divided across many countries, and India is now catching up with at least top two position, if not complete space of that itself. So coming to the straight away getting to Vijay, you've been on both the sides now, academic side as well as the now part of the auxiliary design side of the industry. The reason is already told. You need that. What do you think is a starting point for academic? Is it all starts with the curriculum, I understand, but it can articulate, how they can take a start and lead the both for academic benefit as well as industry benefit.
So thank you, Paul, for giving the overview of what is the industry expectation. Why we are lagging, why our Indian engineers are lagging behind to catch up the expectation of the world, the global semiconductor scenarios. So to say that, so our engineers or our budding engineers are already in the college levels, their basics, fundamentals, physics. So that means whenever you say semiconductor, we need to give more emphasis on the semiconductor physics. Okay? Semiconductor physics with the chemistry details. So it has to come from the C6H6 or SiO2. So we need to start with SiO2, silicon dioxide, and go with that. So we need to give fundamentals where those things are lagging here in our basic fundamentals. The students who are the community, okay, are the academic line, okay, who are the professors are there, and the board of studies, whoever frames the work, okay, whoever frames the syllabus, this one, so they need to consider all the framework, all the nature of requirement which Paul has given, and also the industry. So because I worked in the academic and I'm currently working in the latest cutting node technology with 3 nanometer in the morning. So we are seeing whenever I go to, whenever I take some interview with the freshers, right? So even from the NIT level also, so their basics, okay, even the logic design, if I ask them basic questions, so how do you derive, or what is the difference between a flip flop and a latch? So then, and so they will tell you the difference. Okay, it is edge sensitive and the level sensitive. But then you write the waveform for 10 nanosecond clock period. So then there is no answer. So that is the same scenario which you are getting now. That's why. So my request is that so all professors are doing their work. Okay, I agree that, but the student community has to come up and whatever the world standards are there, so they need to catch up and give more emphasis to semiconductor. So my requirement or my request is that, as Sir mentioned in the morning discussion, we need to bring up a semiconductor branch, VLSI, semiconductor or semiconductor engineering. Okay, so where in PE in semiconductor engineering, then the JSF, this university can apply for it, for affiliation with all the and what we are looking at now is the syllabus. We are not considering the industry experts. I am not saying that I am industry expert. We can consider, we can create a consortium, okay? So wherein we can call, because in every industry, so a lot of things are going to academic, okay, and R&D is spending a lot of money. If I consider my company, Proxy, so they have deputed one resource, senior resource, like 32 years of experience like me to interact with the academic line. So you need to consider all those guys to put it across the table and see where the syllabus is lagging, where we need to give practical, okay, practical exposure. Just come out of the college environment, okay, and piloting the paper and writing the examination. So we need to give weightage, more weightage to practical, okay, practicality. You need to simulate the waveforms. You need to say why it is coming like this, okay, and you need the engineers are deeper why the results are not coming like this. Starting that, so these are the things which you are expected from the academic, from the institutions, and with the industry, from industry aspect of things. So all of us so can share our plan, okay, our details, what is the expectation, we will also come and closely work with you people to close all the gaps. Okay, that I can assure you.
Right. I think, sir, please make a note of that. He's already offered, to support whatever is required, in terms of uh, curriculum kind of a thing, or maybe an activity is required. Coming to Dr. Sudhir, I already mentioned that, I know that being, alma mater of the PS myself, passed out in 2000, the institution has always led from a different point of engagement, knowing, the professor, the son, so John, Taylor Delhi was teaching them in 1998 the basics of thermodynamic science and engineering mechanics. He is the visionary in that way, taking the lead of the industry. You mentioned that you already have a center. Considering there are complexities on the boundaries of the top, the boundaries of the chip manufacturing companies. So the starting point for the COE is at the bottom. Basically, the two elements which is on the electronic design automation and as well as the IP core. So give the flavor, how long it started and how long it is been. So what goes to make such centers in campus?
Thank you. Sir, actually, I will take. I will also talk on then I will come to the center. Case is my experience. I will tell because I am not an academic. I had also the industry and the government and research experience. Before since 4 years, I am in an academic institution where what made me to stay. All my friends are surprised that I'm in the academics, not in the industry. Even after 15 years, 16 years of solid experience in all government industry and all. What made me to stay in academics fundamentally is that academic freedom. Academic freedom means it means as a university we have no bounds to innovation. So I set my syllabus, I teach it, I set my question paper, I evaluate the student. Complete absolute freedom, I think now JC also has got that. That is the first point where the faculty has to leverage on that. The second point is the experiment. What I did was the first thing, and again it is now gradually getting adapted across all departments gradually. So one thing is I just have three components where I have only 50 marks for written exam, 50 marks for assignment, hands-on, and mini project. 50 marks for that. And again, there is no written, in few cases, I don't have a written exam at all. It's only an assignment, mini project, and hands-on experiment. Hands-on doing it. All my subjects, even though all my subjects are electives, I have all these three components. One thing, very recently, now currently I'm teaching 6th semester. 5th semester experience, I want to share, I think it may be useful. Generally in the evening, we have a portal. I teach a digital system design, advanced digital system design with all super things like cloud domain processing, visual domain processing, static time analysis, all advanced topics which will enable them to get the jobs in the industry. But what the experiment with the assignment, we can share with you. Every evening, Tuesday, 8 o'clock, assignment will be uploaded into portal. Portal, we have created a one web portal so that we'll put an assignment there. I had 170 students in my elective. I take a class in a theater. Then all 170 students should submit the assignments in 2 or 3 days. Tuesday evening and Thursday evening will be ready. Something what happens is it's something like a code, right? A Verilog code for means parameterized full adder, something like that. We will do. Within 10 seconds or 20 seconds or 30 seconds, some submission will be there. 8 o'clock sharp, we uploaded the assignment. 8 o'clock, within 8 o'clock, 1 minute, there are some 3-4 submissions. 100% it's a ChatGPT. Take the statement what we have taken, put it onto the ChatGPT, get the code, and upload it as an assignment. We know that this is going to happen. We know that. I had a 4 intelligent TAs, currently in the 8th sem. Currently in the 8th sem, I had them as a TAs for this subject. They only created a portal. Idea was mine. And then we created a one test bench inside the portal. Test bench inside the portal, which will check the code. And also it has got a test bench, which will check the code. If it is a ChatGPT code, we will put 0 marks. Then again, he has to resubmit the assignment, only one option will be there. And again, there will be a bounding. Bounding means if you submit within 1 hour, it will be evaluated for 10 marks. If you submit 1 day late, you will be evaluated for 9 marks. If you are too late, you will be evaluated for 7 marks. Because chances is that you would have taken from your friend code. In WhatsApp, you would have shared, you would have uploaded it into this. Then what is the next innovation? What we did is, don't give any question like this. Write a very long code for parameterized full adder. Don't give any sentence like this. Just write a very long code for the following circuit. Take a pen and paper, draw the circuit, digital circuit, take a photograph and upload it in the code. ChatGPT won't work. It won't work, right? If you upload that photograph into the ChatGPT, it cannot give the code. So this is all the experiences. How do you train the students by genuinely how you can make them work? This is the assignment experiment, right? It means because I had a task of tailing 170 students out of 360 students, 6 sections. 170 students took my elective for various reasons. This was actually a nightmare. Means submitting an assignment was a nightmare. Number one. Number two is a mini project. Mini project is such a way that we all, including me, all 4 my TA teaching assistants, will be assigned with 5 projects and all. I made TAs that you screw them up. Means you have an habit of bragging in the university, but TAs in campus it is not allowed. I am permitting you to brag your TAs. Give the toughest of the toughest. Take every week update. And you have to give an update to me, otherwise I will write. The question is, at the end of the day, what means I will just tell the consequences. Means after that, what happened. By the end of the December, out of the mini projects, I published 3 papers. Not in any small conferences, I published in an Asian Test Symposium. I published in a VDAC. Means we are submitting to that. We already published in December, we published an Asian Test Symposium conference paper. This is 33rd edition, it's a premium one. This is not eligible for any PhD student R&D. It's a 5th semester mini project, subject mini project. It's a very good conference. Again, we have filed one concept is ready. We have already filed one patent on the mini project. The only thing is that we have to drive from the front. We have to drive from the front. Let's say, how do you get the students get ready? They are not there. Means we know that they won't study. As Sir said, they do after batch and flip-flop. If you give some waveform and all, 100% they are not there. How do you make them work? There are ways. Number one. Number two, when it comes to the syllabus needs a drastic changes. Means what I studied in VTU 20 years back, or currently what VTU teaching, I don't know about it, but at least when I joined academics, I was given a full freedom to change all the elements. And also I took the freedom as a domain head of PLSI. I introduced the DSD, advanced the DSD, how to write a Verilog code. That is the first theme, first chapter. How to write a good Verilog code. From that to all advanced topics, all included, where no textbook is there, only my slides and notes are there. Students has to listen in the class, otherwise they will get. Next, changing all the syllabus. And again, when it comes to the WSAT, when it comes to the Foundry, syllabus needs to be remolded in a large scale. For example, to enable our students to get the job in the WSAT or ATMPs, we need to introduce a post-silicon validation, we need to introduce ATEs. I know that ATE introduction is quite difficult, but at least we can have a mini ATEs available, maybe 5 lakhs, 4 lakhs, some investment is required. We have to scale up our bench lab. We have our bench labs, CROs, function generators, we have to a little bit gear up the bench characterization lab. We have to bring one mini ATE or low cost ATEs and introduce a post-silicon validation syllabus into the curriculum in the UG level only, not PG level. UG level, one elective or a 2 credit course, something like that. We have to impart that post-silicon validation training so they will get jobs in testing, WSAT like Keynes WSAT or Tata WSAT or something like that. The one part already I am doing. I'm able to recruit at least 15 engineers in WSATs in last 3 years. From 2021, I am taking post-silicon validation. This is my personal experience I'm sharing. I'm sorry for that. I'm patting my back myself, but at the same tribe, teacher tribe, I'm sharing my experience. Number two, when it comes to the COE, as I said, question, I'm running the COE because only the space was given for me. Room was given. I was to go to pillar to get the computers, furniture done, air conditions done. That's a different story. It happens in whether it's a private or government. The next step is, fortunately, we had a chip to startup project where we have an access to all EDA tools, Cadence, Synopsys, ANSYS, Siemens. All tools are available from the CDAC, full-fledged research licenses. That is, which are actually boosted our COE. Then my COE title is Center for Hardware Acceleration and Chip Security. And in this case, only thing is that I have taken from the university is the space, furniture, and the computer. The rest, everything is self-driven. It all the maintenance cost, all the internship payments I do, all the stipend I give to my students from UG to PhD is generated by own. Means I got a 15 lakhs Qualcomm project, I have a DSP project, CTS, some funds are there. We have to go and sell our idea. We have to go to the companies and say that you have a problem to solve, but you are not solving it because it's not your priority. So you have a second priority project, third priority project, which you are not working, give it to us, we'll do it for free. And again, you assess it every 15 days. 15 days. And if our students solve the problem very well, give them the internship and pay them 3,000 rupees per month. No problem. And again, it has worked with at least 6-7 companies. At least we are doing a project of at least 4 companies as of yesterday.
I need to stop there because the reason is like I have a few more follow-on questions in terms of the.
So this is how the Center of Excellence should generate its own revenue. It should not ask university to fund. Maybe the initial capital we need to fund, then again it has to run on its own.
Only clarity on this Center of Excellence is a part of the electronic department or it is a separate department?
No, it's a part of the electronics department. Without department, I won't get the students. And again, I have to teach it, I have to be part of the department to get the students. Until unless they are not impressed in my class, they are not coming to me.
This is a continuous engagement of the electronics students and people there. Take this as specialized area for the electronics students. So coming to in terms of the grouping on both the sides again, kind of thing. The two sides again. Okay, we are set the COE, we are the one more point always come back to us is the skill set development and industry integration with academia. Right. So we travel between these two organizations more or less almost every time. What is your take on academic setup? What that needs to be done? Skill enablement actually happen along with the study system rather than anything. We gives a little bit of a push, but content delivery itself makes a matter. So with industry required more or less, it still is not there. How do you see that?
Yeah, that's a generic question which everybody is talking about, right? The skill development is actually a very big challenge, and the companies coming to recruit graduates, they already say that, right? 90% of the graduates are not employable. That is very shocking, and that should be taken very seriously by everybody. So what they mean by that is the students, either they are pretty good in their academia and they're getting it there, but at the same time, the lab setup is not catching up. So those days we had good mechanical engineers and electrical engineers because we had the best of the technology already available for our testing and learning. So to catch up with that is a very big challenge. As technologies grow very fast in these areas, it's a challenge. But the base of the technologies stay the same. So at least let me talk about the design software, electronic design automation software. So because these days most of these companies providing the software, they collaborate. They would like to collaborate with the academia for their own interest. So there is no absolutely question on that. They provide the tools at a very minimal cost. It's totally different pricing. Many times it is free. And on top of it, we get help from the government, like MIT organizations like that, like, for any collaboration with the startup or academia, it is almost free. The tools are available, and the training, I'm still thinking how the training is available within the setup. The companies themselves provide the training, because that training is needed even for the industry. Right? So people working in the industry, they do get skilled very often, very frequently. So every 3-4 years, they have to learn new set of tools and methodologies which have been introduced and invented by the industry. So that has to percolate into the academic, in the sense that that training has to be taken by the professors themselves, because it is something getting newly introduced in the industry. So it's like an industry person learning that is equivalent to professor learning it. So we have to see this academia not like just teaching, and at the same time catching up with the latest of the technologies. And there will be some resistance I could see. So even in the industry, when you go to try to sell these softwares between these three companies, what they face is, hey, this is the software we are used to. We just, and many times they don't update it. That is a human tendency. Like, hey, I'm happy with what I'm doing. Why should I go? No, I am in a comfort zone. So moving that is a challenge. But that training from the industry, which is already available, has to be capitalized.
Now the industry runs at an XP computer also software development has gone really way high because of the again the same technology. And then look at all in terms of giving a little bit more insights on just for the benefit of both from Case is Mysore established and taking that the big pitch in this industry, especially developing a fab kind of a center is like even Tata's might have thought about it 10 times. They also wanted to collaborate with any company and wanted to do that. Give that little bit of insights if you have that information. Let us know the Mysore establishment is dedicated to the OSAT kind of a thing, or are we very different?
Okay, thank you, sir.
Leading to that, how you are looking academia for industry collaboration, feed a system for your own requirement for next 2, 3, 4 years.
So it's very surprised to see that exactly 101 participants here, out of which 6 are sleeping because of the good food and the good arrangement, seat arrangement. So Keynes Technology, it's established 38 years back. It's a pure Indian company. The core business is EMS, PCB assembly. So they do the business for all the verticals. They involve in aerospace, automotive, medical, so industrial, whatever you name it, they are doing that PCB assembly. They have 8 different units across India, and apart from that, they are having different verticals. So Keynes Technology is a parent company. Couple of years back, it became public limited, under which Keynes Semiconductor, where I am heading the operations, is a new entity where it will be acting as a OSAT. So that plant will be in Sanand, Gujarat. See, there are 2 differences. I don't know whether you're aware of that, OSAT and ATMP. I just want to give a small clarification on that. OSAT means outsourced semiconductor assembly and test, where we don't have the design of that product. So the customer has the design, they do the wafer fab, they ship us the wafer, and packaging is the only thing. Packaging and the testing is the only thing. This is called the OSAT. ATMP means I have my own design where I will do the wafer fab and I'll do the packaging. So it is a complete cycle. So these are the 2 different scenario, which is as per the government norms, which is called as here. Keynes Semicon, now we just started our building construction in Sanand. Meanwhile, we will have our pilot line there. So we plan to pitch into the legacy packages initially, like the QFN, TO, and some of the IPM packages, intelligent power module packages. Later, we will be move on to advanced packages, BGAs, flip chips. So we already finalized a couple of customers, one from Japan and one from the US. So everything is going well as of now. And Keynes has another vertical called Keynes Circuits, where they will manufacture the bare PCB. That unit will be in Chennai. So apart from that, they are having Keynes Mechatronics in Bangalore, where they are focusing more on the mechanical side. They do the molding, jigs and fixtures kind of thing. So Keynes as an entity having so many verticals which cover the complete electronics ecosystem. So that is their idea. And the next question you asked that how we are collaborate with the academics. So we formulated the syllabus and we have implemented in one of the university in Tanjore. So they have already implemented, I think it is in the 6th or 7th semester. So they have a separate paper for the semiconductors. We actually formulated the curriculum and which is implemented there. In addition to that, we are in discussion with a couple of IITs and other one private university to establish the COE. So the COE that he mentioned is on the design side, but the COE which we are talking about on the assembly side. So we will have the complete equipments inside the clean room facility. The expected area is around 7,000 square feet to have the complete line, where the students will go there and they will experience what happens, how an IC is manufacturing, what are all the critical process. It involves 13 to 15 different process where there are so many parameters. Each process is very unique. You cannot link from one to the other. Everything is very unique. So we want to establish this and we train the students and we will take back the best out of the students from the institutions for our Keynes Semicon.
Thank you. Straight away, pitching that just a couple of days back, we had a discussion with the DPID Chief Secretary of APAN. They wanted to establish a COE on innovation and technology part of that. We would like to offer this space and along with the activity to establish more than IIT like now. This facility in our campus is much more conducive because we are close to our case in terms of engaging with that. Probably come back to you on that in the short. The information. And going back to the fundamental things again, Vijay, do we need to create a separate vertical department? Or we have a starting point where in second year, third year, where we will take the deviation and then create that as a path for both faculties in terms of the research and for the student, take that as the key career. To either can you give us a clarity?
It's a very good question, and so to interact with some of our experts, industry experts, and what I thought before coming to this discussion. So we have VLSI. It can be a branch. Okay. So electronics started there. Started with the parent branch of electrical. In the same way, until we have a solid coursework with what I'm required at this moment, at this juncture is we need to give more emphasis on the laboratory and the practical session, okay, with whatever sir told on the starting of COE. Even we can take first semester students to see when he come out of the college what kind of chipset he wants to do, okay, and what kind of things he will do totally. So it looks like it is motivating for him, okay, it brings in the confidence, okay, after I come out of this campus, so where I would be, okay, and what are my core strengths. That's why we are, so for initial years, right, so we can keep this semiconductor engineering course, okay, semiconductor engineering course under electronics and communication department, and then we can get the affiliation from the whatever, so that part I'm not much because I don't know much about getting the approval and how to take it. If it is a deemed to be university, so then what kind of things with them? Then I can give one framework, okay, starting from, so because what I'm telling you is these physics, chemistry, mathematics, okay, these things are compulsory subjects. We need to emphasize more because semiconductor physics. So if you see what, so if you write the silicon dioxide, if you don't know the silicon dioxide, we cannot get. So what are the silicon dioxide, why it should be taken into the semiconductor. All those things needs to be given with all the technical expertise, with the technical practical experience. So that's why from the first and the second semester itself, we need to create a framework wherein all the activities, all the subjects, all the chapters, okay, with the expertise or with the special attention to practical needs to be given. So that is my suggestion.
Me to say that three electronics department, so one of the branch out kind of things needs to take this lead and then make that.
Yes, yes, yeah.
So in the sense that for the benefit of the left hand side, Kane is taking at top of the things on fab and thing on the proxy level which I present so in terms of the design and kind of thing. When I spoke to Ravi on that, they are aggressively looking at the whole IP core. So that is where they're heading towards that. They end up in getting a support from the case, actually develop the whole chip and taking it to the market and maybe develop the product itself. These are the two extremes which opportunity we are looking into that. COE potentially the area which is mentioned, and Sudhir has started the COE which is already there in the design and IP core kind of thing. So yeah, sustainability is one of the parts always good for COE. Always we look at space and technology is one part, and delivering that an outcome not better than starting itself. However, managing that, what is the insights they can give us.
Stop me whenever I find that it's the cases I take from training. There is a scope for training of the teachers. We enable all teachers, all students with Cadence Digital Batch Program. Cadence Digital Batch Program, Synopsis University Batch Program. So we enable all the faculty in the VLSC domain, and also we enable all the students. Earlier I used to do 150 students to take my electives Cadence Digital Batch Program. They can log into the Cadence site, they can go through all the tutorials, they can write the exam, they can get the certificate from the Cadence, put it on a resume. One student got 14 certificates from the Cadence. He was IFS in options. He's competent. Because the simple thing is that Cadence tools, 14 certificates, and again the pass mark is 96 out of 100. Each certificate to fetch it is 96 in the Cadence Digital Batch Program. One thing what we can do is, this is free of cost. Either Cadence Digital Batch Program or Synopsis University Batch Program, it's free of cost. And all my teachers should try this and get certified. And Digital Batch certified for 15 certificates from
What is the size of the team?
team. COE, frankly speaking, I'm alone running a COE with the help of my TS and everything. That's what actually, that is the, it means it's not that I don't want to collaborate. I have a PhD students who are faculty. I have already a faculty in the department. There are 3 PhD students are there. All 3 are faculty. I cannot depend on them because they have role and portfolios in the department. They work in the center. The city is the center, but at the end of the day, administrative things will go through me. That the policy framework and again approvals, going to the industry, talking marketing, all these things. I need another faculty who can share with me. Maybe one of my PhD scholars get completed. I think they're all in the last.
If I understand correctly, like it's integrated to the kind of into there,
Yes.
the publication and maybe these funded projects which is coming from the corporate.
Means until unless you get the government funding, you cannot run the COE. All the teachers who run the COE or are part of the COE must apply for all government funds, either from the DST, MIT, Ministry of Petroleum, Ministry of Electronics, Ministry of Telecommunication, TTDF, AVEL means National Mission on Cyber Physical Systems. And to means at least every month, yesterday was the last date for external response. Yesterday was the last date. I was unable to apply for various reasons. I had a project in the mind, I did not apply. Now in the next, till by March 31st, I have 4 project proposals and I have to finish and apply. At the same time, my problem is also is that 4 to 5 papers I have to write by March 31st again for many journal papers. These tensions will be there, but In these tensions, we have to run the COE, we have to take the students, take the ED. Again, we have to generate the revenue. This is what exactly happens.
It's all connected, I think.
Until unless you don't get the funding from the government, corporate won't believe you. If you say that we have a funded company, we have EDA tools, we have funds from BST and IT, go and tell to the companies, MSMEs. Don't target Qualcomm, Intel, and all initially. Go to the small MSMEs, small startups. For example, Proxylera means it's a mid-sized MSME. So I think I'm happy to see the Proxylera in the real estate sponsorship. I think the Proxylera is the silicon sponsor or something like that.
Right. Yeah.
Yes. So the question is, mid-sized companies, and again we can, like Proxylera, we can go and talk to them. Ask them to give the themes. Don't give the money. Give the themes. The students solve. That's what I repeated.
Right. And you have some in terms of operation.
Operations, right? Operations basically it cannot be a one-man show. It has to be 3-4 people must be there. At present, I am helped by my TAs and PAs. As a faculty, I am alone, but maybe next 6 months.
Right. So coming to the question, I'm specifically looking at the events happening in this particular industry. Can you give us the trends for the next 5-10 years? How we ready towards that, globally and as well as India specific? In terms of kind of examples we have taken, you already mentioned that you more adding to that kind of. Academia, I also started looking in that kind of spaces where India stands with respect to
So I will start with the academia because I am also kind of involved in one of the projects. Actually, with VTU in Bangalore, I've been part of setting up a COE in a very big way at VTU. And there, what we did was working with Department of Telecommunication, TCOE. So they are ready to fund, and it's you need to bring up a COE, not managing within this with your professor's load and rest of things, the academic load. I'm not sure that is possible. So if you are keeping a dedicated COE, that has to be, I mean, at least there when you're planning big, it has to be a totally separate entity, independent entity, and with a separate management itself.
integrated with it.
Integrated with the departments and integrated with the rest of the colleges. They can all come and learn and have their programs set up. And what is mainly added here, the important part of that is adding the startups. So you are asking for problem statements. They have the problem statements they cannot digest, and they have the ones they want the help of the students. So students are nothing but resources.
This is the learning in very which faculties will allow to their students will go out research that is where they know leading to that whole one question before audience questions. So, I interacted with he indicated that from that side of the operation, they also want to have product side of the aspirations as well. We put out a simple way. How do things look at startup ecosystem or entrepreneurship in current making use of that as one of the area where they can, whichever the way they want to integrate, established out of the campus. Is there a planning place? Is there things discussed within your engagement? You get to know that hey, here is an opportunity. I'm already doing it. Take up the product and also deliver that as well. So I know it's kind of a large challenges, but where do you see these possibilities can open up, especially in Mysore ecosystem?
Yeah, it's a good question. Yeah, our management is working on that direction actually. In fact, we are working with a couple of US companies, the startup companies, on the co-optics packages. So it's advanced packages where we are working with them. as a startup, and we plan to, in fact, acquire them. So similarly, we have find out couple of companies here in Mysore as well as a startups where we can collaborate with them to do the modules. Where in future we will have our own chip into that module, where we will have our own PCB. So it will be a complete ecosystem where as a customer comes into Keynes, he can get the complete solution. So that is a thought process already in place where our management is also working on that.
Just to sum up the overall conversation, what we are in the last 40 minutes, this particular industry cannot be dominated by one company, cannot be dominated by either on the design side of the things or maybe on the app side of the thing. These 4 or 5 elements needs to be integrated. This is where the beauty of the opportunity comes. And also making use of the advanced level of the thing where India is heading towards in terms of having more manufacturing, especially product manufacturing companies are getting established. This is where the government is also emphasizing and putting a lot of money on the table. For example, even DRDO opened up semiconductor college, aerospace kind of a thing. I saw it on so many things. They wanted from the academic perspective as well. Their initial funding is not less than 3 million, 1 billion kind of a thing. Develop, it's a fascinating thing, government is putting a lot of interest in that. Given that kind of a thing where we are sitting, this is an institution, 3 different campuses, having close to a center, close to Bangalore IT hub, and Mysore, also in an electronic hub. Case is leading that kind of a stuff. We have a fantastic opportunities for everybody sitting around here making use of this beautiful network which JSS is already established. So is the only question I can as a faculty, as a student, as institutions kind of stuff. So I request and open up this panel now for questions from the audiences.
Thank you all the panel members for the wonderful conversation. So to set up a center of excellence, this main thing is the funding. So what are the specific avenues for the academia to set up a center of excellence?
Yes, the center of excellence should have some clear-cut objective. Initially, when the people said that let's make a center for realism, then I vehemently approached it should be on a theme. Like we are working on a hardware acceleration projects, we are working on a chip security. Let's take 2 themes: hardware security, chip security, hardware acceleration. Take a theme. Means, for example, we can take a center for packaging and post-silicon validation, and we can. Mysore is taken as Mysore is the headquarter of EMS. From the Ransoms Electronics, who is the pioneer in manufacturing services, to now Keynes is into EMS again in Mysore, right? In Mysore. So where EMS happens in Karnataka is in Mysore. The ecosystem is already in the Mysore. So, and again, Wipro e-peripherals had a EMS kind of line here actually in the early days in the KIDP area. The question is, what means JC can leverage on this EMS or any other thing which is very real point? Why means the people can do with PCB design, PCB manufacturing, and then in contact with EMS, and again they can set up one training centers in collaboration with the COE can be made in a EMS fund. Means my understanding, means I'm talking with respect to the JC perspective. The second aspect is when it comes to the Bangalore is near, and again, not only the Bangalore, anywhere in the world we can do online meetings. It's a global village. So the question is, pick up a theme. Means pick up the theme either in the design or in the. Let's not have a COE in the generic term. I think it might not work. Take a specialization. We do hardware acceleration. In hardware acceleration, what and all we do? We do AI acceleration. We do crypto acceleration. We do post-quantum acceleration. We do DNA acceleration. Means in my hardware acceleration, what is my theme? These are the 4 themes. So like this, we have to get in chip security. We have some list of what we have to do. So focus, policy, and again we should know who is our customer. to which company is working in this area. And again, we need to have a discount the companies. We don't know the people in the companies. We have to go and talk.
And the next
Talk
step
to them.
is
That when it comes to the funding, initial funding should come from the university in terms of space, computers, furniture, tools. This basic set of cases. It should come from the university. The rest is based on the faculty, how much internship they generate for the students, how much government funding they will get, how much projects, how much projects they will get, how much government funding. And gradually that in next 3 years it should come.
If I can add my thoughts on that. So, to have a CEO is exactly to have a real kind of a goal towards what you're achieving instead of making a generic thing. One of that, with respect to what Dr. Sudarshan is working, is on communications. So, communications, if you know, we can have a setup of testing communication. The engineers are so scarce to find. Right? Wherever you go, companies like Keysight could not even find anybody with background testing, and they have set up labs in multiple colleges for a couple of decades. But we can bring in a 5G test lab, example, and that will have a specific goal of making his project, funding whatever he has, to go forward, as well as to government invest on some of these things. They can provide a very nice setup of training on specific network testing to everything what they have using their oscilloscopes and stuff. Once you put that, we don't want to really stop with that particular thing. After this project is done, it will be lost, and that will be the typical worry, and that is kind of the past it has happened. So you can have a program to skill the original way of skilling this forward coming students. You can bring them all into the program, and the program can be designed by the startups or the company which is providing this. This is hardware we are talking. So also they have additional software together. So, but there is going to be an investment which involved. There will be discounts, but we need to get funding from government and college itself, and the cooperation and certain cooperation from everybody.
Maybe I can add a few points because I'm from a packaging side. So just I want to give the clarity. In India, we are having plenty of design engineers, but as I already mentioned, we don't have a packaging engineers in India. So if you want to have a COE, it would be good to have a complete packaging line. And I request all the faculties to be trained in that first. You need to understand what is the packaging. Not only the packaging, there is an assembly testing and reliability, failure analysis. So semiconductor is a very huge area where you can learn many things. So if you have a curriculum in your syllabus and if you train your students, I guarantee that 100% of your students will get jobs for the semiconductor industry. So as mentioned, you have to have an objective to have an COE.
questions.
Before some days, I have seen the government notice from DSL. They are hiring some workforce for the fabrication lab, but they are conducting the interview in Singapore, and they are hiring the workforce from Singapore. There is any opportunity to the India, and they can train the students in TSMC company because they are providing 1.5 year training in TSMC company for the Singapore students.
So that is the concern in India we have. In fact, in Keynes, we have two expats, one from Malaysia, one from Philippines, because the talent pool is not available in India where we need to depend on them. But the other way around, there is a university in South where they have a tie-up with Tata Electronics, and they have a program, MTech program. First year, all the students will be in the college. Second year, all the students will be sponsored by Tata. they will be in Taiwan for the 1 year time frame where they will get the practical knowledge. After that, all the students will be absorbed by Tata Electronics. So that is the kind of scenario where the universities are working. So if you have that kind of approach, definitely we can recruit our Indian people. It is not necessary to get people from abroad. We don't have an space to have it. That's why we have to move on to look for the talents from outside India.
So basically, it's a chicken and egg scenario, like whether we wanted that first or so we need. That's why we are talking about why we need a COE kind of a centers adding into the specific core area that will trigger the interest with the organizations or maybe companies to closely work with academia. Then other things will follow, and the experience and expertise will develop over a bit of time. So jobs is not kind of a thing. There are plenty of things, but are we preparing in that right direction? Are we preparing in even to address the futuristic kind of a thing right now? Because that is the number of job requirements keep coming to even for the startup as well. The same challenge for the why the startup is struggling to move this. Only few people are available. The rest is again the dependency. So that's why it's really tough to take that. But if this case kind of initiative happens, we see much more organizations coming and then laying an next level of accessories or maybe design companies integrating and making possibilities as well.
I think what whether it should be a separate branch like electronics and communication is there, computer science is there. Now the newly AI/ML has been invented. And again, in the same way, the more few colleges in the Bangalore and the BTU, even a few NITs may have a BTech in VLSI design. I think that was the question. Yes, I mean, if we have a BTech in VLSI design, not a bad idea. But at least we should have a balance in the curriculum in such a way that it should include at least one communication course, one DSP course must be there. Again, we should also have a full-fledged ASIC design flow from genesis to functional verification, formal verification, testing, problem analysis, physical design in 2 semesters. Then again, GenAI for VLSI, EDA tools, completely post-silicon validation, packaging. Everything must be blended in such a way that either they will get a job in ATMP or SAT side, or they will get a job in defense. The students should be equipped to get job in all the 3 sections. All the 3 sections, at least in at least 2 sections. One is the design, verification, testing, power analysis, physical design. Another part is packaging, WSAT, testing. The BTech curriculum for VLSI design or semiconductor technology or whatever the name we keep, it should be enable the students to get the job in the both the ecosystem, packaging, testing, post-silicon ecosystem, and also design ecosystem.
I would like to quickly recall what happened in this area in the Silicon Valley 25 years back when there was shortage of semiconductor engineers. University of Santa Cruz introduced courses in the Bay Area and which were just taught by the industry experts themselves, the evenings. So they have arranged, in fact, I took very lot of courses from them. So it was real-time things get from the real industry experts, and they have prepared their own coursework, and they can be included in the academic program, however. But that was so useful. You take physical verification as one course, and then whatever you're interested in backends. Moment you finish all the backend courses, you may get a certificate from them. That kind of things will really help to get that thing. Your badge idea.
So I'm just putting this question for both the academia group and as well as industry. So as we understand that electronics means not only the chip design, so it goes beyond the chip lab and it goes to the board level and subsystems level. So in academia, the students would have a lot of ideas in their mind, so they do that. So to take that from that conceptual stage to the solution stage, so it's a journey basically. So somewhere in the middle, students do the part of the work and they just go. And what I see is how you can see that the students can be made part of this design work so that they can be given weightage, and we can call them as co-inventors, whatever the way. So that is the question for the academia group.
Question. So how we have to mend our student community is that, so there are so many open source codes, open source RTLs are available from Dinesh, Anaya, so as it is in Git, okay, so even we are also taking that part and we're improvising that one. We can take one small module inside that risk processor. Okay, first you teach them the block diagram and you give them, you assign you divide it into some batches and give the instruction decoder how the risk processor works, okay, and you can assign the individual blocks, okay, and assign the blocks. They can experience because I think we are being a very big university, so we have funds for the EDA tools. Right? So starting from synthesis, okay, we have cadence, all the way you can take the RTL and run down till the physical design implementation. Okay? And we have also student version licenses from media vendors. And when we have some COE kind of things, so they will give very elevated or the discounted price. Then, so they will see the ecosystem. So if you introduce these things in the semester itself, so the RTL coding, okay, the modification to this one, or parameterization, as we said, okay. So all those things we can introduce those things and they can experience the real feeling how the actual design in the RTL, okay, how it is getting modified in the gate level when it is targeted. So what my request is that get approach with some okay, where they can give the PDKs for the real library sets, okay, with at least some 14 nanometer. We need to target 8 nanometer so that they can experience what the real problems we have and get those things and feel the feel of because if you see the medical thing, right? So they will do anatomy and all the dissect everything and see the similar way what we are doing. The main problems we are facing now is we are not getting the skilled engineer with all these capabilities. When you come to physical design, so physical design, some engineers will they say that it is fully automated because EDA tools are there. It will do the your synthesis. So synthesizer will do the synthesis. Then you will do the physical design tool, EDA tool, ICC tool, or in-house tool will take all the way from the gate level nexus to silicon. Okay, but that is not the truth. Okay, there are so many complications which I emphasized yesterday. PPA. These parameters needs to be regularized. Okay, needs to be regulated on each and every stage of your ASIC design flow. So first you need to understand what is ASIC, what is the difference between ASIC, FPGA, and all those things, and then slowly introduce to these curricula. So that is what the expectation from the semiconductor physics or semiconductor engineering or so that domain specialization may be the name may be different, but the curriculum must contain emphasis more on these things, and you can assign that to some different activities. That's what I hope I answered your question.
Yes. So I just try to address the industry group also. See, basically in VLSI you depend more on the highly sophisticated software, okay, and their usage, which you call it as tools. How do you support these tools to be developed at the college level and all? As I was mentioning, open source and all, but still, because because the industry too much depends on the high level sophisticated tools. But at the same time, that need to be nurtured at the core level. So how do you support this open source industries software tools?
So yeah, developing a full-fledged tool is something which industry is taking. At the same time, maintaining the tool and adding additional, we call it wrapper scripts and scripts to maintain is something which is actually needed for the designers and which had to be taught even to the designers to maintain. So there are lots of things. So this is where multiple curriculums merge, right? Like you have an expert in software who's doing CS, and he doesn't have the domain knowledge of electronics. Interdisciplinary concept will come naturally, will come because all the electronic engineers will have some kind of coding knowledge. So whoever gets the coding knowledge will become developers into software. Rest of them will be better off with doing only the hardware. So they will not have. See, people's mindset, that's how it works from what I have seen, right? So the experts will have multiple patents in designing hardware, will not understand the smallest concept in software, they will not understand. So, that doesn't mean, and that is how it should be, and that's how it is. So there is opportunity.
For the Keynes, so you are using tools. So how do you support open source for your tools? Do you support open source? Because you are using tools.
Sir, as far as the packaging industry is concerned, there is no such software is available. So the softwares are belongs to the process related only. So machine related only. So that cannot be outsourced. That cannot be in the open market. Each supplier has their own software where we have to train to run that particular equipment based on the vendor's software. So this is the packaging side. But for the test engineering, there are common softwares available where that can be incorporated into the testers according to the test platform. So that can be done. Any more questions from the lady side? More than 50% of the ladies, no questions from them. Perhaps ma'am this morning asked about this 136 pyramid. So that can be easily done because since you handle one particular department, you know all the candidates. Maybe the PhD candidates, they have one guide. But even then, within the group, you can know the people, whether they are PhD or BTech or MTech, where you can find out the similar mindset of people and you can form a team. This has happened, this is already in place in some of the universities where they are getting more funding and more projects. So the main thing is that in most of the industries, the universities, there is one institution industry cooperation cell is there. If you have such kind of cell, their core job is to move to all the industries. Wherever there is a hike or where new technology comes in, they have to go there, they have to sign an NDA with them, where you can send your students to the industries to do some projects. You ask that where they can be a co-author kind of things that can happen. So having a relationship with industry is a key where you have to develop that.
Right. Uh, Thank you very much. Just to sum up the kind of things happening in the semiconductor space. Just a couple of days back when Invest Karnataka event happened, first half a day session is only on semiconductor. Industry people talking about the investment, the machine side, the wafer side, the design side. The people are, looking India as an opportunity space for starting the, establishment, developing solutions, and also the product to the global good kind of a thing. And even in the same case with, Aero India, where there are closed door discussions around, on the electronics and semiconductor thing, indigenous manufacturing of the, the product, the solutions which is required, and that is why the defense side actually put a lot of money onto the table to develop the kind of a thing. Today, when in Mysore, we're talking about cybersecurity kind of a thing. The conference is going on in Mysore. Just I dropped in and came back that the whole idea is again like even that cybersecurity is again the rooted come back to can I make my chip intelligent so that I can take care of the whole cybersecurity thing rather than the software side at the chip level itself rather than at the latest stage of the part as well. And even tomorrow we are launching technology development entrepreneurship course. So we're talking again on the taking AI and then connected with these topics itself. So last 4-5 months, Mysore has seen surge of activities around the same topic. Investment part of it, small companies to the large companies visiting the Mysore and looking at where they can establish a kind of a thing. Mysore is going to be an R&D for this. Definitely, we are seeing that kind of trend coming in. There's a title says scaling the future. Scaling the future is not 1 or 2% responsibilities. All of us need to take part in it and own it and then make the opportunity worth for it. Challenges again throws a lot of opportunities. That's why we're talking today. Otherwise, we will not come together and then have this particular topic has been discussed. That's why the opportunity is big and it's just not a big, but it is very large. So thank you very much. Thank you all the panelists.
you very much, sir. It was really a very eye-opening session, which we had a panel discussion with the two current topics on the opening of COE, Semiconductor Technology and Academic Institute, and the scope for the UG and the PG courses in Semiconductor Technology. We wholeheartedly thank for on behalf of the Department of DCE. Firstly, I would like to thank the moderator, Sri Shivshankar sir, who is the Chief Executive of SJC STEP, Mysuru. On behalf of the department, I request Sudarshan Patil Kulkarni sir to give a small token of gratitude to our moderator of this session, Sri Shivshankar sir. Up next, I would request Dr. S. Gayatri madam to give a small token of gratitude to Dr. Natarajan Krishnan. Dr. S. Gayatri madam to give a small token of gratitude to Dr. Natarajan. Dr. Sujata Swami madam to give a small token of gratitude to Sri Paul Ilangovan, who was represented from the industry for this panel. And I request with Dr. N.G. Veena madam to give a small token of gratitude to Dr. Sudhindra Kumar, who was represented from the industry, academic. Ms. Veena madam to give a small token of gratitude. I request Professor Tyagaraja Murthy sir to give a small token of gratitude to Mr. Vijay Kumar Murthy, who was also represented from the academic. Thank you very much to all the panelist members who have been come over here all your way and share your expertise. Just a couple of seconds, we are going to start with the valedictory program. I hope the participants have completed with the feedback part. Yes. I hope you've received the acknowledgement mail to your email. Yes, perfect. That should be fine. So you can basically collect your certificates post to this session, that is valedictory session. Professors from JSS AT Bengaluru can collect from Professor Megha KM and Anupam. It's just exactly the same point of your the same session hall. And Professor from JSS AT Noida and JSS Polytechnic can collect from Professor Madhusudan and Professor Vinay Prasad. And professors of JSS STU can collect from Professor Shalini and Usha. You have been requested to submit the workbook before you collect the certificate as per the instruction from the coordinator.
Owing my head to the lotus feet of Sri Suttur Guru Parampare, Sri Suttur Veera Simhasana Mahasansthanamata, taking the divine blessings of Swamiji and JSS Mahavidya Peeth. Very good afternoon, esteemed dignitaries, respected faculty members, distinguished guests, and the dear participants. As we come to the close of our 3-day professional development program on the scaling the future, trends and challenges in semiconductor technology, it is a time to reflect on our journey, celebrating our learnings, and expressing our gratitudes. Education is actually the kindling of the flame, not the vessel of the filling of the vessels. This is the insightful quote reminds us that the knowledge gained over the last 3 days were well served as a guiding light in our professional paths. Let us now take a moment to look back at the enriching sessions we had till now. To provide a brief overview of this professional development program and to welcome all, I now invite Dr. U.B. Madheswamy, Professor and Head, Department of PCE, to take over to the overview of this.
Offering my most respectful pranams, the Lotus Feet of Sri Suttur Guru Parampara, JSS Mahavidya Peeth. Good evening, everyone, respected speakers, distinguished guests, and dear participants. I am filled with a sense of pride and gratitude. This program, organized by Department of PCE, JSS Science and Technology University, has been a remarkable journey of learning, collaboration, and inspiration. Over the past 3 days, we have delved deep into the world of semiconductor technology, exploring its strengths, challenges, and opportunities. So all sessions were good. Drawn speakers from premier academic institutions, leading consultants, and top academicians from the leading industries. So they have given a very good insight to the semiconductor technology, starting from the silicon to the application. So I hope you all carry this knowledge, use this to deliver the content to your students, open the Center of Excellence at your institutes, incorporate this in the syllabus. Now I take the privilege to welcome guests, our Honorable Vice Chancellor, to this valedictory function. I welcome you, sir. I also welcome Dr. P. Nanjaswamy, the Controller of Examination, to this event. Thank you, welcome, sir. I also welcome Dr. Surendra Kumar, Professor PSID, Chief Guest. Thank you.
Welcome you also for this valedictory session, sir. Thank you for the encapsulating the essence of this program so eloquently. So feedback is actually the bridge that connects the learning to the improvement. As the saying goes, the feedback is the breakfast of all the champions. Now it helps us to grow, evolve, and also refine our future programs. I now invite some of the participants to share their feedback and expertise from this professional development. I request Dr. Sudarshan Pandit.
Taking the blessings of Swamiji, thank you for giving me opportunity to express my views. The 3 days workshop. Congratulations to coordinators for the excellent arrangements. And we must thank the participants from JSSAT Bangalore and JSSAT Noida for making this whole event a success. So it covered for 3 days the entire spectrum of semiconductor industry, the design part, packaging technology, And even on the aspect of research, we had the keynote talk. He talked about the cutting edge research of semiconductor moving towards more neuromorphic kind of technology. Then we also got to know about the growing trends in the industry, what the demands in various verticals and horizontals for the semiconductor. So overall, it was a totally enriching experience. And to conclude in the panel discussion, so we got some various like leading lights to start how to start a center of excellence in the semiconductor area. For that matter, any so what all are the inputs required? And we are now feel confident that behind us we have these luminaries. Anytime if you need some help, you can always approach them to seek their inputs. So with that, it has given us that kind of confidence. So thank you very much. Finally, we should thank the driving force behind this kind of activity, our management, Director Technical Education, Vice Chancellor, Registrar, and entire management team of JSS. Thank you.
Sir, for the valuable feedback. Can I request with Dr. Arun Kumar, please? Sorry, Professor and Head of JSS 18. Good afternoon, everyone. Respected dignitaries on the dais, respected panel members, resource persons, and my dear faculty members. So first, I would like to thank Department of PhD, JSS STU Mysuru for organizing this 3 days PDP program, and we are here because of this initiation by JSS Mahavidyapita. So this is the first PDP in the Mahavidyapita, and earlier FDVs was arranged for other faculty members, but here we got an opportunity to attend the program and to gain the knowledge. In these 3 days, we gained the knowledge from the basics, from semiconductor to implementation of the IC chip, and with this knowledge, we'll return to our institute and we'll plan and we'll train our students. Since from 1 year in our department, we are training the students in the field of VLSI, and our team members are working hard. And after attending this session, we gained much knowledge, and we have networked with resource persons and experts. With this, again, we'll work hard to train our students. And also, after attending this session, yesterday, luckily, we got Vijay Kumar sir in the guest house. And since I know Vijay Kumar sir since 10 years, and yesterday he had given very valuable inputs. We had a discussion, huge discussion around 8 to 10 p.m. in the guest house, and he has given very valuable inputs. And with these inputs, again, we will train our students, and also we also upskill our knowledge in the field of VLSI. And at last, I would like to thank the organizing team, especially Dr. Rudraswamy sir, because he is actively coordinating and arranging this FDP along with this team. And also at last, I thank HOD EC, Dr. Madheswamy sir, for organizing this event. Thank you, sir. Thank you. Thank you, sir, for your valuable feedback. Can I request with Dr. Veerabhadra sir, Associate Professor, JSS 88 Bangalore.
Here. Thank you very much for organizing this event in this campus. Advantage what we received is we have connected all the 3 institutions together in this event, then shared and gained our knowledge. And the second thing is Also getting a good networking with all expert persons. With this, thank you very much for everyone.
Thank you all. Any others who wish to give a feedback? Any other participants? Okay, thank you. So as a token of appreciation and acknowledgement of your active participation, we now proceed with the certificate distribution ceremony. I request our esteemed dignitaries on the dais to kindly present the certificates to few representatives. I just followed their names. Dr. Arun Kumar Ji, Professor and Head, KTE Noida. Dr. Veerabhadrappa, sir. Associate Professor, Dr. Yatish KC, Associate Professor, KTE Noida. And I request Dr. Chandrasekhar, Associate Professor, JSS KTE Noida. From JSS KTE Bengaluru, Dr. PM Shivkumar Swami. And I request with Mr. Ganesha HS, Assistant Professor, JSS KTE Noida. And I request with Dr. Purnima M, Assistant Professor, KTE Bengaluru. Next, Mr. Basuraju NM, Assistant Professor, JSS KTE Bengaluru. This touches Rupanjali, who is a lecturer at JSS PDA Mysore. Mrs. Jagadamba M, lecturer, JSS Polytechnic, Kanchapur. Mr. Shiv Prasad KM, Senior Lecturer, JSS Polytechnic of Pune. Congratulations to all participants. Thank you all deputies for joining hands. The remaining certificates will be distributed close to this session. Now, to formally bring this program to a close, I have an honor to invite Dr. A. Santosh Kumar, sir, Vice Chancellor, to deliver the closing remarks.
Good evening, everyone. The outset, I submit my most respectful lotus feet of His Holiness, Swamiji, and Divine Blessings. Dr. Sudhindra Kumar K. Combined Real Science Design and Embedded Systems, University of Bangalore. Colleague Anjun Swami, Control of Exams, Madhya Swami, the ENC department. There are program coordinators, Swami, all the invited speakers and guests who are present here, all my colleagues from the Constituent College as well as the university, participants from JSS Bangalore as well as JSS Noida, and from university also from Noida. And all of us who are present here, including like some from the politics. And I am
extremely happy that this 3-day professional development program, Scaling the Future, Trends and Challenges in Semiconductor Technology, was successfully conducted by the Department of Electronics Communication. So, at the outset, I would like to congratulate Dr. U.B. Madheswamy and the entire team of the ENC department. So, put up a very good show. I think we should all put a round of applause for them. They have planned very meticulously, almost every other day. Like, I used to see U.B. Madheswamy in my office for one or the other reason, like, regarding this particular workshop. They spent a lot of effort, like, in time organizing this, including all the coordinators. Congratulations to all of you. For all the participants, this is the opening remarks also, like, I mentioned this. This is a very unique program that, like, we tried out, and I think for the first time we assembled, like, all the 3 institutions together. And it's the first attempt, and, like, based on this success, we're also going to have some more. In fact, already planned, like, coming up next month, right? 26th of 5 days program on artificial intelligence. So we have already, like, thought people again are coming from these 3 institutions as well. It's a great opportunity, like, what the management is us. Slightly couple of, like, feedback when they were giving this. It is given opportunity to network. Probably within the department, we don't meet one another very often because of various reasons. So somebody has a class, somebody has a laboratory, we'll all be in one particular. We have friends from different departments who go there. But here is an opportunity where, like, people are meeting across, like, board from 3. So I think probably it's an opportunity to also, we are in fact, like, talking to Professor Suresh also, to jointly host an international conference. Because this has given us, like, the feedback. And we are also, like, very happy that this has also given us the strength to go and tell the management. We are not capable of, like, doing something bigger than this. In the first, like, introductory session, Dr. Navtan Bhatt was talking about, like, how the contribution of Indian is only 2% related towards the global semiconductor technology. The present government, like, wants India to be a semiconductor hub. Some of the very small countries, as you all know, like Taiwan, South Korea, and all, they are doing wonderfully well in terms of research in semiconductor technology. With all the, like, brains that we have, all the institutions, academic institutions, we have some brilliant minds here. Why is that, like, we are not able? Why is that we are only happy to just import things? Why can't we come out with our own, like, that is the whole question, and we wanted to see that everybody gets an insight into the exciting opportunities the semiconductor technology industry itself offers. That's the whole reason why we have, like, I think now it is your responsibility to go back to your, like, respective institutions and start training your students and the other faculty who have missed this. It can't be only from ENC, somebody else is interested in your own institution. Conducting workshops in turn. Even it could be a 1-day workshop, right? And, like, try to transmit whatever you have learned here. So, as I said, the future is very bright. Has got a lot of prospects. We have got some very amazing talent, like, with us. Major domain experts. I see some of them here. Like, the last year, also some experts were here. Also told that, like, some of the sessions were very excellent. Right? Not normally we don't get to hear from these people because they are busy. We don't call them. Right? But here's an opportunity, like, which was provided to listen to some of these people, interact with them, right? So that we can also, like, gain of knowledge and clear some of the things which still be there. So you can even beyond this also you can keep in touch free time and try to interact with them and please remember there is also first day no conversion. There's a flip side to it. Any of these technologies that we are coming. Every other day, we try to develop technology one after the other. Right? Always there is a flip side to it. Right? I think our friend Semiconductor is here. Right? So we opened a center of excellence, sustainable IT. I think a couple of weeks back, right, with the HSE step. There, we're talking about data centers, etc. One of the major energy consumption areas today in the world is on the training on AI itself. People are being trained in AI big time. Right? So any technology which comes, training is required, so much of energy consumption, so much of manpower. Whether we can sustain all these things, we are not very sure. So I think we should also consider that. End of the day, this kind of technology should help somebody. And take the the economic responsibility. And moreover, everybody should be comfortable with this. So you should have that in mind as well. So very happy that we have this one, and I was told some people are in a hurry. This is the last part. So I told them no, this one and all speech and all that, field certificates and so. Some people have to go back. Some of them not even go to Ooty and heard. Maybe you can go there and enjoy. You have to. So without taking much time, I once again congratulate all of you, especially the panel. I'm definitely sure you're all carrying a very positive thing with you right, when you get back to your institutions. Thank you very much. I also thank the management for supporting us in this particular. Thank you one and all.
Thank you, sir, for acknowledging with the insightful and the inspiring words. As we conclude, it's a time to express our heartfelt gratitude to all those who contributed to the success of this event. To deliver the vote of thanks, I now invite Professor Punit K. Assistant Professor, Department of PCE.
Good evening, everyone. So, seeking the divine blessings of Sri Sudhir Guru Parampara, this esteemed guests, faculty members, and dear participants. So, it is indeed an honor and privilege to extend a vote of thanks on behalf of the organizing team at the valedictory session of today's professional development program on scaling the future, trends and challenges in semiconductor technology. A heartfelt thanks to our chief guest, Dr. Chirendra Kumar Kesar, for taking the time to grace this occasion and share his invaluable insights on the panel as well as in the session. His words have been a source of inspiration to all of us. A special thanks to our today's sir in his absentia, Director of Technical Education Division, Mysore MVP, Mysore, for all the support rendered in organizing this PDP. We are deeply grateful to our guest of honor, Dr. A.N. Santosh Kumar Sir, Vice Chancellor, JSSSTU Mysore, for his esteemed presence and encouragement throughout this program. His support has significantly contributed to the event. A special note of appreciation to our registrar, Professor Dr. S.A. Dhanraj Sir, in his absentia, for his unwavering support in organizing this event. I would like to thank our controller of examination, Dr. P. Ranjan Swami Sir, for making time. A special note of appreciation to Dr. C. Nataraju Sir, Principal in charge and Dean Engineering and Technology in his absentia, for his unwavering support and leadership in making this program a reality. I would also like to extend my sincere thanks to program convener, Dr. V.B. Madheswamy Sir, and program coordinators, Dr. Rudraswamy Sir and Dr. P. Rakshit, for their meticulous planning and seamless execution of this program. Their dedication and hard work have ensured that everything ran smoothly. A warm thank you to all the faculty members and staff of the Department of Electronics and Communication Engineering for their contribution in various capacities and making this event a very grand success. I would like to thank the Deputy Registrar, Assistant Registrar, Dean, Associate Deans, Finance Office officer and universe beneficiaries for all unconditional supports and knowledge. I further extend my warm regards to JSS AHER for the support for accommodation and travel support. I also thank Manjuna MMRC for video coverage and live streaming. So special thanks to Photon Club for photo coverage. A special mention to the technical staff and student volunteers for their behind the scene efforts. Often the most crucial contribution go unnoticed, but we won't take a moment to acknowledge and appreciate your hard work in ensuring the smooth conduction or smooth execution of all the sessions. From managing the logistics, sound system, and event coordination to handling technical aspects, your dedication is invaluable. Last but not least, a big thank to all the participants of their active engagement and enthusiastic participation. Your presence and interaction have enriched this program, and we hope you find it insightful and beneficial. Further, I would like to thank Principal of JSS ATE Bangalore, JSS ATE Noida, Principals of JSS Polytechnic for deputing their faculties for this program. With this, I extend my heartfelt gratitude to each and everyone who played a role in making this event successful. Thank you all once again.
Thank you, sir, for acknowledging the efforts of everyone involved. With this, we officially conclude the 3-day professional development program. Thank you all for your active participation, insightful discussions, and unwavering enthusiasm. Wishing you all a continued success of professional endeavors, safe travels, and see you again for the future. Certificates can be collected immediately after the high tea, which is being arranged. Please proceed towards the high tea and come back again to the same seminar hall for certificate collection.